All right, this is an introduction to what we're going to call logarithms, but logarithms is such a long word, so I'll call them log, L-O-G, log. Okay.
We're your like funnest trust, right?
Oh.
I like your shirt.
Oh, okay. Thanks. I was like, is there something on me? Okay. Sorry for the interruption. We're going to do the warm-up. 2 to the x equals -8. The class has already thought, and nobody has come up with an answer yet that is at least correct. What? 2 to the 3rd would be +8.
No, -2.
This is not a -2. So 2 to the -3 would give us 1/8 because the negative exponent just reciprocates. It has no power to change that 2 into a -2. What do you? Nope, it's not 1/3. It does not matter. So just so you know, 2 to the 1/3 is the same thing as the cube root of 2. Again, that's not going to change it into a negative number. There is no exponent that I could use that will change a positive number into a negative number, even though some of you did that on the last test. There is no exponent. So if I'm asking you to solve this and we can't solve it because there's no solution, I will write no solution. So the second warm-up that I put on the board was 2 to the x equals 0. So if I say x equals 1, you are telling me 2 to the 1st equals 0? No. 2 to what exponent will equal
0.
nothing? 2 to the 1st equals 2. 2 to the 0?
If it's
2 to the 0 equals 1. Anything. Hey, what I'm saying right now is going to keep coming up. There's a reason why we're starting with this today. So now 2 to the 0 is 1. So yes, if you guessed, this one is no solution. Oops, I just erased the whole problem. This problem is also no solution. Oops. 2 to the x equals 0. That's also, both of these are no solution. You cannot take a positive number to an exponent and have it be anything else than a positive number. That's going to be important for something that we do later. All right, and then the third thing that I gave you on the board was 5 to the x equals 7. This is not no solution. Did anybody get an answer? Okay, so we are going to learn how to solve this at the end of class. This is the last question we're going to do today. This does have an answer. Did you find something? You can just guess x's. It's basically at this moment, right this second, all you can do is guess and check. Start picking x's. What's 5 to the 1st? 5. What's 5 to the 2nd? 25, way more than 7. So it's somewhere in between 1 and 2. Well, that's guess and check at this point. I'm going to show you how to get the exact answer for x without just guess and check. Go ahead.
Question.
Yeah.
Could exponents be decimals?
Sure. They can be fractions too, because we did that on the last chapter, remember? If I have 2 to the 1/3, I had this a moment ago, but that's the same thing as the cube root of 2. So this right here, that's a fraction which could be a decimal, right? I mean, 4 to the 1/2, that's the same thing as 4 to the 0.5. And that means square root of 4. So yeah, they can be. And this would be a decimal answer, this one that we're going to find at the end of class. But you'll just have to wait. All right, the next stuff, if you have not learned any of this from another teacher and you started working on it, without me telling you what we're going to do, you probably have an answer, but we're totally going to do it a different way. Did anybody already like figure out 2 to the x equals 16? What'd you get?
4.
Right, 4 is the right answer. I don't care that you can find the right answer. What I care is I'm going to show you how to use this new thing that we're doing called logarithms. So I'm using something that we already know the answer for so that you can see something new. All right. So what we're learning today are called logarithms. Here's the word logarithm. You can just abbreviate log. I'm going to use the word log many times because logarithm is like a lot of syllables. All right. And what logarithms are is they are inverse equations or inverse operations of what we just studied in the last chapter, exponential stuff. Now, what's inverse? We've talked about inverses before. Kind of opposite. Kind of. The word opposite means something specific in math. If I have x plus 7 equals 10, how would I solve that equation? I would subtract 7 to solve this equation. So what we're doing is we're using an additive inverse, and you don't have to write additive inverse down. I'm just explaining to you the word inverse. An additive inverse would be adding or subtracting. Those are opposites. The word opposite in math means plus or minus. So that's why I said kind of when you said opposite. So we're doing the opposite operation. That's an inverse. It's like what undoes addition or subtraction. Another example, 3x equals 40. What would we do to solve this? We would divide by 3. Well, that's because multiplication and division are inverses. They undo each other. That sounded awful. And then if we had x squared equals 25, what would we do? We would square root because square root, and we would also have plus minus, but that's a different story. Square root and squared are inverses of each other. They undo each other, right? So the question is, what undoes a base of 2 with an exponent? What undoes a base of 2? It's called a logarithm. So I'm teaching you today that a logarithm will undo a base. So when I put in a log, that's just like trying to solve an equation where I put in a square root to get rid of the squared. It's just you've never seen log before, so it seems hard. Where you saw square roots for a lot, like prior to my class. You've seen them before. You've just never seen log before. So what I'm going to do is I'm going to take this equation and I want to cancel out the 2 so that I just have x by itself. So what I do is I use the inverse of this base of 2. The inverse is called log, but we have to specify this is going to be a log base 2. So this little 2 is, it's kind of like a subscript where it goes down below. We say log base 2. That's what we say, log base 2. Next to that log base 2, we have 2 to the x. So I'm putting it in the equation to undo the 2. Yes.
Log base 2 is always there, right? You don't change anything.
I don't know what you mean.
So, like, are you saying log base 2 because there's a 2 and the
Yes.
equation? So
I am saying log base 2 because there is a big 2. When we do the second question, you'll see that the base will be different. Okay. So I'm purposely choosing a little 2 down there. All right. Now, I do want to let you know that there are understood parentheses here. So you're not always going to see the parentheses. That was an ugly one. But you're not always going to see the parentheses, but there's parentheses here. Okay? There's some there. So really this is saying log base 2 of 2 to the x. All right? On the other side, if I do log base 2 on one side of an equation, I have to do it to the other side. The exact same thing I did on the left, I have to do the right. And then we've got that 16 sitting there, and that 16 is going to be in parentheses, but they won't always have the parentheses written. So I'm showing you that there are parentheses there, but you don't have to write them. Okay, So all I did was do something to both sides. That's what we do every single time we solve an equation. All right. Now, before I go on, I'm going to need to do what I'm about to do. I'm going to need to do this eventually. So I'm going to do it now, but we'll learn why I do it eventually. 16, I would like to write 16 as a smaller number to a power because I'm going to have to do it eventually. So I'll let you know I'm going to do it now. What is 16 as a smaller number to an exponent? 2 to the 4th. Okay, I'm just going to replace that really fast. So we really have log base 2 of 2 to the x equals log base 2 of 2 to the 4th. Okay. Now, I purposely used a different color for the thing that I put into both sides of the equation so that you can follow me. What we're going to do next is a property that's on like the 3rd page of notes. I'm just going to tell you what the property does. I'm not going to remind you about it every single example, but there's this property that says if we have a log and then we've got a base and there's an exponent on that, we can take this exponent and we can bring it in front and multiply it in front of the in front of the word log, sorry. So my next step is going to look like x log base 2 of 2. So I just took the exponent. It's called the power property. You put it in front. It becomes a normal sized thing. So up when it was an exponent, it was teeny tiny up there. When it goes in front, it becomes a normal sized thing. On the other side of the equation, I kind of have the same situation. I have a 4 as an exponent after the log. So that I'm going to do the same thing with. I'm going to move it in front and make it multiply. So I've got 4, and that now becomes a normal size 4 times log base 2 of 2. Okay. Now, I told you the reason why I chose log base 2 is because it is the inverse of the base of 2. So these undo each other. I can cancel them. They're inverses. They undo each other. Just like addition and subtraction undoes each other. Just like multiplication and division undoes each other. Just like a cubed and a cube root, they undo each other. On the other side, I have the same thing. Log base 2 of 2. So what's the only thing left? X equals 4. Now, we already knew that answer. I would not need logarithms to solve that problem if I already knew that it was x equals 4. I am using logarithms so you understand how to solve harder ones. All right, we're going to do another one just like this, different numbers, so you can see it a second time. So I'm going to start with 3 to the x equals 81. And I need to get rid of the base of 3. The only thing that cancels out a base of an exponent is a log with that same base. So to both sides of the equation, I'm going to log base 3. So notice how the 3 is tiny, teeny tiny. It's a little base. And then 3 to the x is normal. The 81 is normal. I just put in a log base 3 to both sides. The 81, I could take to a smaller number, to an exponent. What's 81? 3 to the 4th. Okay. So I'm going to rewrite this as log base 3 of 3 to the x equals log base 3 of 3 to the 4th. So now my power property says if I've got an exponent in this spot, I can move it in front and multiply. And I happen to have that on both sides. So I have x log base 3 of 3 equals 4 log base 3 of 3. And then log base 3 of 3 are inverses. So they undo each other. It actually equals 1. And so really what I have here is x times 1 equals 4 times 1, so x equals 4. Coincidental that it's the same answer as the question before it. But you saw we used a different base for that one, all right? The next two examples don't have directions because I forgot to type them, but the directions are not solve, because do you see an X here? No. So the directions are not solve. They are evaluate. Evaluate means find one value. You are going to find one number that this is equal to. Evaluate, we're going to find one number. So when we find one number, I will no longer have the word log sitting there. So I'm going to use the logarithm to do it. So I'm going to start thinking to myself, this has a base of 4. If I can rewrite this as log base 4, and instead of 1/16, if I could take that and write it with 4 to some exponent, I will be able to get rid of the log. So where my brain goes is 4 to what is 1/16. All right. So you all said it, but I'm making a video, so I'm going to explain. One thing I know is that 4 becomes a fraction by using a negative exponent. So I know for sure it's negative. And then 4 becomes 16 by squaring. So -2 would be that exponent. Now log base 4 and a base of 4 undo each other. That -2 goes in front. So my final answer is -2. So far, every single time we've seen a final answer, it's been an exponent. Bless you. So this next one is also evaluate. So I've got log base 7. And I would like this to say 7 to some exponent so that the 7 and the log base 7 can cancel. And we talked about this at the beginning of class. 7 to what exponent is 1? 0. Anything to the 0 power is 1. So that is the exponent. And then log base 7 and 7 undo each other. The exponent goes in front. That is our final answer, 0. All right. Now, because the exponent just goes in front every single time it becomes a big number, I don't show that step. I just cancel, it's 0. But I didn't want anybody wondering why an exponent that's a teeny tiny little number up front becomes a regular big number. It's because of this property, but I've showed you it 4 times now, so I'm not going to keep showing you it unless I feel like I need to remind you. Okay. Before we go to the next part, we're going to look at our calculator for a moment. And I want you to find on your calculator, and this depends which calculator you have for just this moment. It's not a big deal. On the graphing calculators, it says x squared. On the red ones, it says like, it's like x2, and I think it might have like a box there. Okay. And if you have, I don't know what it looks like on yours. Do you have an x squared button? Yeah. Okay. Right above the x squared button on the graphing calculators, it has a square root. Right above this button on the red calculators, it's like a root with a little box here. What's it on yours? Square root? You got square root? Yeah. Okay. So why are these on the same button? Because they're inverses. That's why they are the same button on your calculator. Because they're inverses, they undo each other. So now I want you to find, and it is in the first column, I want you to find the button that says log. And near that, I want you to find the button that says LN. They're in the first column. I do have a calculator up here. ln.
Oh, it's below it.
Yeah, so there's my log button, and then there's my ln button on the graphing calculator. If you're using the red calculator, it's in a slightly different spot, but it is in the first column. What is written right above log is 10 to the x. These are inverses of each other. What is written right above ln? E to the x. These are inverses of each other. That means when we are canceling stuff out, here's the inverses right there for you on the calculator. Of course, a lot of things we're going to do today are not calculator, but we will get to do calculator stuff too. I just want to show you that they are located together because they're inverses. Now, the log button is not every single log we're going to use. So like how we were using log base 3 and log base 2, this is not log base 3. This is not log base 2. This button right here, it is a log base 10. So if you see log by itself, it means log with a base of 10. It's called the common log. We do numbers in powers of 10. We tens, 20s, 30s, hundreds, thousands, 10,000, 100,000, million. Those are all powers of 10. So this log is the common log because it is a base of 10 log. Okay. And I will show you how to do log base 2, log base 3 eventually. That's the last thing that I will do today is show you how to do it on the calculator. So don't worry, I will show you that. I was going to say something else about this, but I can't remember. I don't know. But when you see log, because you will see log by itself in the assignment, that means log base 10. The other button, the LN. LN stands for, it's called the natural log. That's what it's called. ln is called natural log. We did E last class, and E is called the natural number. And E was like approximately 2.718 or something. But the natural log means log base E. But we'll never write log base E. We're always going to write ln. All right. The paragraph that's right below where we're writing, that paragraph, this is two of the things that are in that paragraph. I just wrote it down instead of having a paragraph because you guys don't always read them. And then there is one more thing in that paragraph, and it has to do with the very first warm-up that we had today. You will never, ever, ever have log with whatever base. You'll never have a negative or a 0 in this spot. So this will always be positive. So you'll always have log with a base and of a positive number. If you have a negative number in this spot, or if you have a 0 in this spot, doesn't work. Okay, so that's the third thing that's in that paragraph. All right. So now we're going to, for the rest of the class, for the most part, we're just going to do examples. And then your homework is just like the examples, just longer. And once you've done a few, they go fast. All right. Oh, yeah. So I just explained log when it doesn't have a little base written there. When it doesn't have a base, what is this base? 10. So this means log base 10 of 1 over 100. Okay, that's what that means. And I'm writing it now because we're doing notes, but usually I don't write it. All right. In order to evaluate, and I don't know if the directions say it, but that's what we're doing. I mean, there's no X. We're just evaluating. Evaluate. In order to evaluate, I want to do what I did above. I want to rewrite 1 over 100 in a base of 10. So I'm going to rewrite 1 over 100 as 10 to the what exponent? -2. The negative makes it a fraction. The 2 makes it 100. Log base 10 of 10 cancels. This is -2. And then the next example says ln e to the 3x. If we have a log and ln is a log, it is log base e. If we have a log, this 3x can go in front, become normal sized. And ln and e are inverses of each other. So our answer, 3x. So ln and e, they undo each other. Okay. The directions are important. If you don't use your notes, you may not really understand what the directions are. So please use your notes when you start your assignment. We're going to change from logarithmic to exponential. So right now you look at question A, there is the word log sitting right there. So what we're going to do is we're going to get rid of the log and we're going to put in an exponent. You see there's no exponents right now. So we're going to get rid of log, we're going to put in an exponent. That's what we're doing. So we're going to do that, and this is an equation. Yes, it's an equation. So if it's an equation, I'm allowed to do things to both sides, as long as I do it to both sides. I can do whatever I want. So what I'm going to do, and here's a vocab word for you, is I'm going to do exponentiate. Exponentiate both sides. Exponentiate both sides. Exponentiate. So I see a log with a base of 7. What is a log base 7 the inverse of? A big 7 with an exponent, okay? The log's already there though, so I need to give it the big 7. So what I do when I exponentiate is both of these sides become exponents. Become exponents, okay? Both sides of the equal sign. I'm going to give it a base of 7 to the log base 7 of 343 equals a base of 7 to the third power. So whatever you do it to both sides. That's why I'm changing the color so you can automatically see that I put a blue 7 on both sides. And whatever I do, as long as I do it to both sides, I can do whatever I want. So now, just like the log base 7 will cancel out the base of 7 if they're in the other order, just like this, they'll cancel out. So as long as the 7 and then the log base 7 is in the exponent, they'll undo each other in that way, and I will get 343. On the other side, it's just 7 to the third. Now, I am not asking you to find 7 to the third, because what is 7 to the third? You already know what 7 to the third is. I'm not asking you to do that. I'm asking you to get rid of log and have an exponent in the answer. I just did that. I'm done. This is literally like do one thing and stop doing anything else. Just stop there. This is to practice switching between the forms, which is what we're going to need when we solve equations. So question B, we're going to do a similar thing. First thing I need to know is what is the base? 10. So we're going to exponentiate by putting a base of 10 and log 10,000 is now the exponent. Other side, base of 10, -4 is the exponent. The base of 10 and log base 10 cancel. They're inverses. We get 10,000 equals 10 to the -4. Justine. Because I made that up. I have no idea. Maybe the side of my eye, I saw the equal sign and thought it was negative. I don't know. Thank you. Is that your question also? Yeah, my bad. Because I'm seeing who's awake, and I definitely know who's not awake. Would you like to lose your seats today? You do? Okay. All right, next one. We're not solving, we're just switching the form. So we're going to exponentiate. What should be my big number? 3, because 3 is the base. I'm going to put a base of 3 to both sides. Log base 3 of 5. 3 and log base 3 cancel. We get 3 to the y equals 5. And we are done. We went from log form to exponential form. If you are stuck, if you are confused, these are places where you stop me before I change to the next topic. So the top of the next page, we are kind of doing the same thing, but we're going backwards. We're going from exponential to logarithmic. So I'm getting rid of the exponents. I'm putting in a log. So what cancels out? Let's see, the exponent is on the 6. What cancels out a base of 6? A log base 6. So in a different color, you can see I'm writing log base 6. 6 to the 0 is still there. Other side, I'm putting in log base 6. 1 is still there. These undo each other. We get 0 equals log base 6 of 1. You don't have to do anything else. There's no like real amazing reason why I'm doing this. This is just to get you used to switching forms, which you'll need to do when we solve. So this is to help you get used to a procedure. Question B. I need to cancel out the base of that exponent. What's going to cancel out a base of 10? Not 10. What is going to cancel out a base of 10? Log, are you saying log base 10? Okay, so log 10 doesn't mean log base 10, so please. Log base 10. But when I write log base 10, I don't write log base 10. I just write log because it's the common. Oops, I meant to make that in a different color. Oh, no. That's the common log. So I just write log 10 to the negative 3. But I need to know that that log is base 10. Okay? So that log base 10 and the big 10, the base of 10 cancel. We get negative 3 equals log 0.001. Yeah, and honestly for this, I just I have like box equals. Yeah, it's like there's like an A, B, C where you're just gonna like, this is like A, B, C or something like that because you can't really type that in. But yeah, it's pretty obvious how to type them. Yeah. Okay. C. What do we need to cancel out? We need to cancel out the 16. So we're going to use log base 16. Cancel, cancel. We get 1/4 equals log base 16, 2. Done. So I'm pretty sure the assignment's even in the same order as our notes. We're now on example 3, and these will just be the same kind of thing in your assignment. We actually already did this on the other side. We just have more to practice with, and some of them are a little tricky, so we'll go through them together. All right. So we're simplifying without the use of a calculator. Notice without the use of a calculator. And when we do this, there is no X. I am not solving. I'm evaluating. Okay. So in order to evaluate, we want log base 5 to match up with 5 to some exponent. What is 125? 5 to the third. Okay. So you're going to use the powers that we've been working on that whole last chapter that you've gotten definitely way better at. And the answer is the exponent. The answer is the exponent. Log 1. What is my base? Okay. So if you need to write it in, that's fine. So 10 to the what? 10 to the 0 equals 1, right? So this is a 0. So what's my answer? The exponent, 0. So normal 0. Okay, so here's where it gets a little tricky. I need the big number to be 32. Do you have a question? I'm so sorry. Oh, you already know? Okay, give me one moment to write it down then. Okay, so I need this 2 to be 32 to an exponent. That's what I need. Okay, so this is going to be a 32 so that we could cancel them. What I need to know is what that exponent would be. 1/5 is correct. How did you get 1/5? That's exactly it. So 5th root of 32 means 32 to the 1/5 that we studied in the last chapter. The 5th root of 32 means 32 to the 1/5. So that's its exponent. So our final answer is 1/5. So if the number is getting smaller, like if 32 is bigger than the big number, you're probably doing a fraction. Okay. How about this one? What's the last thing you said? Exponent 1. It already is like gonna cancel. Yeah. The exponent is 1, so what's our answer? 1. Remember, the log base 5 undoes the 5, and you always just get the exponent. All right? So this one would be like log base 3. So we need to make this 3 to some exponent. So 3 to what exponent is equal to 1 over 81? I heard a 4. Oh, -4, right. So the negative part will make it into that fraction, and then the 4 makes it into 81. So these cancel, we get -4. Okay? F, we need log base 2 of 2 to the exponent. So we are not solving. So I'm not going to write no solution, but I am glad that you already realized, because I told you earlier, we can't have a negative here. Now, I'm not solving, so you will not say no solution. That would be when we're solving and we can't find the answer. This phrase is undefined. Again, we're not solving, so that's why we don't say no solution. All right, we're almost done. The next section, almost the last section, the next section is solving. So we're going to solve. What time are you leaving? Oh, okay. We'll keep you longer. All right. They'll call. We are solving for x. And this is not the strong point of this year's Algebra 2 students. No offense, not your fault. Because Algebra 1 kind of wasn't the best. What? For some of you, yeah. For some of you, some. I'm just saying like the order which you solve. So we need to get x by itself first. We got to undo stuff. Can anybody tell me the first thing that I need to get rid of to get x by itself? What's the first thing that I need to get rid of? What do you think, please? Yeah. What do you think?
I would say like inside of it, but then it's already solved down to that, so I would say log 3.
So the log base 3, is that what you mean by log 3? Yeah. Log base 3 is the first thing we need to get rid of because that's like the most outer thing. We always kind of get rid of the layers until we can get down to where the x is. So log base 3, we got to cancel out first. How do we get rid of a log base 3? We do a big 3. We exponentiate. Okay, so the same word again. Exponentiate. So we're going to make a big 3 to both sides of the equation. Log base 3 of x minus 3 equals big 3 to the 5th. So I did it to both sides because I have an equation. I'm allowed to do that. That 5 turned into an exponent. So what I did was I made a base of 3 on both sides, and I moved both sides up to the exponents. That's the same thing that we did right here on example 1a, where we were just changing the form. So that's really what I'm doing, is I'm changing it from logarithmic form to exponential form. But I also have to solve on that one. Here we didn't need to solve. Somebody said they had a question. Was it Karina? Okay. So I'm exponentiating. So now when I do that, the 3 and the log base 3 will cancel. And we will have x minus 3, normal x minus 3 left over. On the other side, 3 to the 5th, 243. Okay? Now I can add 3. X equals 246. But remember when we were doing solving in the last chapter, we were needing to check for extraneous solutions. I will show you how to type it in the calculator if you want to be using your calculator for the check. I will show that to you. Haven't showed you yet. So you're just going to have to take my word for it because I don't want to like use all of the time that this does check. Okay? Yes.
So when the parentheses x3, when everything else like goes, that's why it comes down with the parentheses. Since the 3 and the log 3 canceled out.
When these cancel out, yeah, it comes down as x minus 3. Yep. Okay, so each of these is slightly different. So we won't do the exact same thing for every single question here, but then you'll have examples to use with your assignment. So we've got log base x of 343 equals 3/2. We need to get x by itself. You see that it's log base x. The 343 does not need to go. What needs to happen is x needs to not be here. So I'm going to exponentiate both sides. I'm going to get rid of log. I'm going to change it into exponential form. But what is my big base that I'm going to use to exponentiate with? X. That's okay to use x because that's the base. It's okay to use x. So now we have x to the log base x of 343 equals x to the 3/2. Now, when I do that, my big X and my log base X cancel. And so now I have 343 equals X to the 3 halves. So now that log doesn't have a little base of X. It's X is still there, but it's not in an uncomfortable, weird spot. Okay? That's probably you. So next thing that we're going to do is we have to solve for X. You don't have to yell it out, but think for a moment. Okay. So we got through this stuff. All right. So in order to solve for X, does everybody know what we need to do? By the way, this was the stuff on your last chapter. We could square both sides. If we square both sides, I'm not going to multiply out 343 squared because technically this is a non-calculator question. Okay? But if we square both sides on the X side, I will get X to the third equals 343 squared. I'm going to leave it there. I'm not multiplying that out. What should we do now? I don't want to because it's a non-calculator question. So there's got to be easier way of doing it. So I'm not going to multiply it out. What should we do now? How do I get rid of the cubed? I need to cube root both sides. Do I need a plus minus with a cube root? No. So that cube root and that cubed are going to cancel. I will have X equals the cube root of 343 and squared. You can do either the cube root first or the squared first. I'm going to cube root first to make it smaller. Then I'll square root that answer. If you don't know what the cube root of 343 is, it's on the first page of the notes that we just did today. Anybody know what it is? 7. Okay, so the cube root of 343 is 7, and then we square that, so X is 49. Okay, and you can plug it in to check it. I'm skipping the check because of time, but you can use your calculator to check once I show you how to use your calculator. All right, next one. What should we do to both sides? Big 4, base of 4. So we're going to do big base 4 to the log base 4 x times x minus 12 equals base of 4 to the third. Before I move on, what is that called when I do big 4 to both sides? It's called exponentiate. I'm exponentiating. That's what I'm doing. Okay, so that will cancel out the 4 to the log base 4, and we have left over x times x minus 12 equals, and that is 64. Now what should we do? Distribute. X squared minus 12x equals 64. We have spent a lot of time solving these. If you still don't know how to solve them, you got to get help. We've got an x squared and an x. What are the methods? And subtract 64 is not a method. What are the methods? That is what I'm going to do. But what are the methods that we have to solve this, Justine? Quadratic formula, and there's something else. Factoring. So if you said guess and check, you meant factoring. Okay. So in order to do either of those methods, we have to subtract the 64 because it has to say equals 0 to do those methods. All right. Now, because of time, I'm going to factor and solve it really fast. It's x minus 16. It's x plus 4. We get x minus 16 is 0. So x is positive 16. We get x plus 4 is 0. X equals negative 4. We got 2 answers. We need to check those answers. Okay. We're going to check them. One of them I'm going to check in particular is the negative 4. The reason why, because of time, I'm not going to check 16. It works, okay? But the negative 4, the reason why I want to check it is because remember, we cannot have log of a negative number. So if I'm plugging in a -4, we better just make sure that's correct. So I get log base 4, -4 times -4 minus 12. So I get log base 4 of -4 times -16. And what's -4 times -16? So we get that positive number there. It should be fine. But if you plug it back in and there's a negative, you got to throw that answer out. So both of these answers do work. Alrighty, 2 more. ln 2x minus 3 equals ln 11. We need to get rid of the ln to get the x by itself. How do we get rid of an ln? What's the inverse of ln? E. Now remember, on your calculator, it's e to the x. So to both sides, we are exponentiating. We're doing e to the ln, 2x minus 3. We're doing e to the ln 11. And then wherever I have an e to the ln, they undo each other. And this is a really easy one because it happens on both sides. And now we have 2x minus 3 equals 11. Add 3, divide by 2, and you get a 7. You check it, it works, okay? This part's not the important part because we should be able to do that already. Last question. What do we do first to solve the equation? Get rid of e is not the first thing we do. We need to get rid of the 5. Okay, so this is, we get rid of the most outer thing. So we're going to subtract 5 first. So we get e to the x plus 1 equals 15. Now we can get rid of e. To get rid of e, e is exponential. So we got to go logarithmic to get rid of e. And we're going to use log base e, which is ln. So to both sides, we're going to put ln in front of e to the x plus 1, ln in front of 15. All right? ln e cancel. We get x plus 1 equals ln 15. One more step, take away 1. So we're going to start our calculator lesson in just one moment. Once I write this down, this is the answer. This is an exact answer. This is ln 15. Take away 1. Now I can't take, so remember I told you there's understood parentheses here. So we can't take away the 1 from the 15. All right. So we're going to start with our calculator. I'm going to find an approximate answer on the calculator, but I want you guys to type in ln 15 take away 1 and see if you can get the correct approximate answer that I'm going to put on the board. I want you to think about how you type things in. There's a button, ln 15 take away 1. I'm rounding to 3 decimal places. Did you type it in correct or incorrect? Is it 1.708 on your calculator? Then you did it wrong. And I know what you did, and I'm going to go over it in just one moment. Well, I know what I did wrong. You do know what you did wrong? Yeah. It's 1.708. So every person in here should have just tried it. If you didn't get the right answer, I guarantee this is what it looks like on your calculator. You did ln automatically opened a parenthesis. You typed 15 minus 1 and you hit enter. What you didn't do is tell the ln to stop because the minus 1 doesn't get subtracted from the 15. So if you didn't put that parenthesis in, that's what you did wrong. Okay? Did it work? 1.708. Yeah, 1.708. Okay, the last thing I'm going to show you how to do is the very first question we did that I told you was coming. All right, I am on the very top of the next page, just at the very top. The question isn't on the page, but it kind of is. So the very top of the page, this is the question I asked you at the very beginning of class. This is our last example. You won't have any of these in your homework, but you will have them in class tomorrow. But these won't be in the homework right now. Do you have a question, or you just know how to do it?
Can I ask, or can I guess the answer?
Don't guess the answer yet, but you can guess how we're going to do it if you want.
Oh. Okay.
I don't know what the answer is. I don't have it in front of me, but so 5 to the x equals 7. We need to get x by itself. So what should I do to both sides? Log base 5. We're going to log both sides. We're going to do a log base 5 of 5 to the x equals log base 5 of 7. That will cancel out the log base 5 and the 5. Remember, the x goes in front. So we have normal x equals log base 5 of 7. This is the exact answer. That's the exact answer. I'm going to give you the approximate answer, and I'm going to teach every single person in here how to type it in any calculator. But this log base 5 of x is lower down on our paper on this page. Just so you know, because of time, like we're not going to do this ever this year. We're not going to do this, and we're not going to do that. We're just doing this right here. Okay, so there's the log base 5 of 7. So I'm going to show you how to type that in the calculator. I'm going to show you how to type it in any calculator, and then I will show you specifically, if you have the graphing calculator, a different way of doing it. But if you forget your graphing calculator and you have to use another calculator, do not expect me to teach you during a test or a quiz how to do it on a different one, because I'm going to show you right now how it works on every calculator. So how it works on every calculator is you're going to type in log 7, and then you're going to divide that by log 5. So that's the log button, the log that is base 10, 7 divided by log 5. So right now in your calculator, type log 7 divided by log 5. And you should get approximately 1.209 unless you typed it in wrong. If you typed it in wrong, you probably didn't close the parenthesis. So make sure you close that parenthesis. All right. Does anybody need help with typing this in? So could you type in this one? So we're going to do log 3/7 divided by log 12. So the base goes to the bottom when we do this. That's the bottom one. All right. The base is the bottom one. So type in log 3/7 divided by log 12. And you should get negative 0.341-ish when you round it correctly. Did you get it? Okay, so I've taught everybody how to do it. Now, specifically, if you have a graphing calculator, there is another way to do it, which I'll show you. But if you forget your graphing calculator, I'm not teaching you how to do that. That's something you need to know. So don't forget your graphing calculator, or just do it this way every time because it works. The other way, here's my graphing calculator. You would go under math, and then under math, you just arrow up until you see log base. So you arrow up until you see log base, you hit enter, and then it just lets you put the 5 and the 7 in. It is easier. You forget your graphing calculator. I'm not teaching you the other way. Okay. What? I don't know what they are in your calculator, but when I stop the video, I can come look. Under my calculator was math, and then there was a log base.
Did you just find that by everything?
Oh no, I know. But I teach a way that works for everybody because not everybody has the same calculator. Okay, so you guys, your lesson is completed for logs. You do have a question, 49 questions, and you have to type it in Canvas. So you need to start now. If you don't want to write down every single question I think this is it. When you go to it, when you start it, I'm showing you right now, when you start it, the questions are written there. Like the questions are written there. If you have a paper copy, you got the questions there too. So if you want to do it on Cami first and then go type your answers in, or if you want to just go here and type your answers in, that's fine. Okay. All right. I think that's the end of the video. Let me know.